into it. Uh, s- so let's dive in. So as you can see, I have this folder for our AI.SEE assessment. I haven't started anything. We're going to do it with cursor. So we're going to web code. Um, yeah. So first, let me put the model and yeah, the image that we've been given to this folder. So I'll copy and paste paste it here. Mm, yeah. So these are what we're going to use for this whole project. Uh, so our next step should be setting up some rules for our AI agent to make our uh, process easier. So we're going to do that by uh, introducing a file on our root folder called .cursor rules. So I'm going to add my cursor rules here so that our agent will follow this through the whole project. Mm, yeah, I have already created my cursor rules using an AI to make it a little bit more standardized and so that our tone is clear so for the agent to build this assessment. So yeah, I'm gonna copy and paste it here. As you can see, this will be my cursor rules. So yeah, we can go through them one by one. First, I tell my agent that it only works inside this current folder. I wanted to set up a new environment, a Python environment, and it will be working for different operating systems for Windows, Linux, MacOS. And I also want to use the latest Python version, which is 3.9. And I will also wanted to add some starter packages for this. I think I might also need Matplot, but we will add it later. Uh, yeah, I have already handled it here. Mm, I might not need this for the first one. Yeah, okay, so these are related for the Onion for the offset versions, for it to default back for the stable one if it does not work for the one we want. Uh, yeah, and another we will generate comparison images. So I want I am telling the agent how I want the image to be generated, so that it will be easier for me to compare the outputs for the different models for the PyTorch model and the ONNX one. Uh, yeah, so this is pretty much our rule. Um, okay, next, like, let's try setting up our project. Uh, since we have the model, we want the image and the rules. Now I can proceed to defining our like structure and start working on what the what the agent needs to do. So let's start. Um, create a clean. I wanted to build a clean architecture or project structure for the project we'll be doing using Python. So create a clean Python project structure for converting, and we can also deploy it later. YOLO models. Uh, we can specify a little bit further to let the agent know what we want. So I want folders like include folders for models, uh, scripts, scripts, and outputs. Um, and also an asset folder to put the image in this folder. And then I wanted to add and also add requirements txt with the packages I will be using for this. Uh, mm, for converting, let me be a little bit of specific for the agent so that we will be converting a PyTorch model to an or in NX format and do an inference with both models, and finally deploying it. We might not want to deploy those, but hmm, let's leave this for now. I added this part so that it can install the package that we want. So let's start. Mm, so let's wait for our agent to complete our workflow. Great. All our folders have been created. Mm-hmm. Yeah, that's great. We have our image in our assets folder. That's that looks like that looks pretty neat, I believe. Um, okay, okay. Now, yeah, it also moved our model to our models folder. Okay. We've also added the packages that we want for this model to work. So actually, I will have almost 3 or 4 steps. The first one being this figuring out the structure for our project, and then we will we will proceed to loading the model and preparing it. And there's also another step we will the model conversion from the PyTorch to the ONNX one. Um, yeah. Uh, so we might also add optimizing the model, uh, and then also we will run inference on the converted model. And finally, we will also compare it, perform comparison. Yeah, that's what we will be doing in general. Okay. We have, oh yeah, the agents also has given us a beautiful README file. As you can see, this project demonstrates how to convert a PyTorch YOLO model to ONNX format and perform inference with both models for comparison. Yeah, that's pretty much what we want. Um, and here, this will be our project structure. Yeah, and it has also given us how to set up our project. Yeah, this is nice. Mm, yeah, so I think the agent has finished. Yeah, performing inference points with spin up, yeah, directory structure, main files, yeah, requirements. Mhm. It has also added two files for, yeah, in the scripts, model utils.py, okay, it's the matrix structure, and also utils.py file for pre-processing the image. Yeah, letterbox, post-process detection, as I pretty much covered it. Mm, so let's keep all and continue to the next step. Uh, Link. Mhm. Yeah. So our next step will be loading the model and preparation. So now I will add the pre-trained YOLO model using PyTorch Hub, which our goal is to extract ready to export format. So mm, write a Python script that loads that pre-trained YOLO model from the models folder, and yeah, we went to verify it by running inference on a sample image, image that is under assets folder, which is called image2.png. Yeah, man, I might not need to uh, explain that. I mean, be specific, you can find it, but I just can't help it. Yeah, which is called image2.png. So, and I want an output image that will show me the entrance of the object detection. Okay, yes. So now what the agent will do is it will at the model, and it will verify it using the image we've been given, so that uh, we can we can see object detection. Okay, interesting. Now it's running the it's initializing our environment. Mm, yeah, okay. Mhm. Mm, yeah, I think it's running the command. Mm, it might take a few minutes. Okay. Initialize the setting up an environment and always using this environment is pretty much an easier uh, way of building things. Uh, since packages are updated most of the time, it's a good approach to specify which version of the package we're using for a model, so that it will be reproducible easily the next time we want to uh, run our project on a different timeline or on a different machine. So always our little environment will have everything it needs to run the project and do what we want to do afterwards. So uh, it's pretty quite good approach. Mm, okay. Yeah, might need more time. Mm, yeah, so that's the model. It's the image. Yeah, so it specifies where we will need our output image to be. Yeah, okay. It also tries to create our folder for putting the output image. Yes, so it loads the model. That's interesting. You can see how it has become easier now. It does all the stuff all without any help. Mm, It might take a minute here. Yeah. Uh, mm, okay. It's an installing the necessary package till now. Mm, let's wait till it finish. This is taking time. Um, okay. Uh, it took its time, but it was it finished the task uh, that I gave it. So as you can see, uh, previously, like I did told the agent to load the model and try to verify it using the image so that it works. And I asked it to give me an output of the labeled or the image that the objects that it the model detected from the test image that I gave it. So like I think we're finished with that task. Uh, the more the agent was able to, I mean, uh, it did load the model, the images, and it ran the model on it. And after that, it was able to uh, generate the output with the labeled objects, as you can see, yeah, as you can see here. So we can totally say that it identified it with a good confidence. I mean, 0.95 for the giraffes, for the car, and for the bench. Uh, it seems to do the things that I asked it to do correctly. Uh, yeah, so we're done. No, so it did also give me the if summary here, uh, what the script used for the YOLO implementation. It uses the Ultra Analytics package, yeah, which is quite good. Uh, the agent did build it quite accurately. Uh, so if we're done with this, I mean, we can we can proceed to the next part, which is model conversion from the PyTorch type to the ONNX format. Uh, like I've explained it before, I mean, this conversion is quite useful because ONNX is a universal format and it can be run anywhere. So that's what we will try to do on our next task. So let me describe what I want from the agent. Mm, so uh, create a script that will convert the YOLO model, the YOLO model that we have uh, to ONNX. Mm, and I want it to be set under models. Uh, mm, mm, Rather, we can save it in the output since it's we get it from the out. Like it makes sense to put it in the outputs. The outputs directory as YOLO model. So next, um, we can also include a dynamic access and the variables export. Oh yeah. So now let's convert the model to an ONNX format. Mm, Let's wait for a few seconds till the agent finishes. Yeah, so as I told it, the agent tried to do the do the task I gave it, but it found that some of the packages were not installed. It proceeded at automatically to install those packages that we don't have in on our environment, uh, and it got finished with that. So now, yeah, uh, it also built the script for converting the model to on ONNX format. Now it's trying to create a script to verify the ONNX model that we have output. As you can see, we have the model on our outputs directory as we want. Now it's trying to run the inference with the image we have. Uh, yeah, while trying to create the model, I did I did specifically told the agent to include a dynamic axis and verbose export. Uh, this this means that I want the dynamic axis means that we want to export the ONNX model so that it can handle variable batch sizes, so that it would be flexible with many images it processes at once. So that would be a good approach for us for later uh, on. Um, I've also the verbose export one would mean that so that I can see that uh, I mean to see that each layer being converted in real time. I might not really need it for now, but it's as a good approach when trying to change models from PyTorch to or NNX. Let's check if our agent has completed. Oh no, it's still working on it. Yeah. Uh, okay. Seems to have found some issues with our ONNX model output format, but it's trying to fix it by its own. It's updating. I don't think it will take that much time, but if it does, I will pause the video, not to take much time. Somehow the agent is not putting our files, convert all Linux, verify model, verify Linux files to the utils for the scripts folder. I think I needed that. Okay, now it's finished. It's running the updated verification script. So yeah, okay, okay. We have this output. Let's see. Okay, yeah, I didn't do it. I didn't do it well. Mm, it's rerunning while fixing the issue. Mm, okay. Oh, interesting. Interesting. Hmm. It seems to that it has worked, and the comparison seems a bit similar. Yeah, but it wasn't able to identify search output or an index output. Okay, okay. Seems similar. It seems working. So it, it's given me an overview that it has worked. I've successfully created a script that converts the yellow model to O and index format and verify it works correctly. Okay, created, yeah, model verification. Okay, so it says PyTorch model inference. It took 316.8 milliseconds. Or the ONNX one will take under 16.5 millisecond. Oh, it was 2.7 times faster. It's demonstrate okay. Yeah, it also used the dynamics for fast dimension. That's nice. That's what we want. Uh, but now what? Some of some of the files uh are in the root folder. I want them to be moved to the scripts directory to keep it to make it clean and also mm, I want one single image of that contains the original one inference from the PyTorch model and mm, PyTorch model and the one inference from the ONX model. And also, okay, this will be enough for now. Let's see them. Let's clean our folder structure. Plus, let's compare the labeled images side by side to see the difference. Mm, yeah, so far so good. I mean, it's clearly working well. Mm, mhm. Oh, this is nice. It's, it's cleaning our files very well. Yeah. After we're done with this, maybe our next step can be try to visualize the performance comparison. I mean, I'll try to compare the performance between the PyTorch and the ONNX models to showcase the efficiency gains. We've already see the little summary done by the agent, but maybe if we can try to visualize it with some images maybe to highlight why the model conversion and optimization matters. Uh, yeah. So let's finish with this and let's finish with this and we'll move to that. Okay, okay. So now they're running the inference. Oh, look at that. I mean, now it's really clear. Yeah, it seems like everything is in place. Hmm. Yeah, we're almost going to the end. It didn't take us much time. Yeah. Let's check our outputs. Yeah. There's a comparison PNG image that has been created for us. Perfect. This really looks nice. Oh, it seems that it's really the same. I mean, mm, yeah, 0.89, 0.83, 0.85. The accuracy seems to be similar with it. I think it's nice. Mm, yeah. Mm, nice. Okay, once it is finished, mm, mm, first in inside storm mode equals pose. It has also updated our requirement.txt for all the packages that we need. Yeah, it has also updated our README, moving the script to the script folder. Yeah, we want to keep all here. Okay, now the agent has finished. It has organized the project structure, quality, high quality comparison image that shows original image by source model that we've seen. Uh, where is the output? Yeah, here. Yeah. Okay, perfect. Now that we have figured that out, our next step should be the performance comparison. So let's tell our agent to compare the two models. So mm, uh, add benchmark benchmark py file to the scripts folder and use let's write it prior to this. Compare the inference time between the PyTorch model and O ONNX ONNX model using some test runs, some test runs, mm, something like something like average latency and the speed up ratio, speed up ratio, speed up ratio, and other. Write it on that. Okay. Let's wait till this finishes. As you can see, it's running the benchmarks as we told it to be. It has also, yeah, it gave us the comparison here that the inference on the ONNX model is 1.52 times faster. Uh, yeah, okay, so we got the benchmark results. Okay, uh, okay, so it gave us a benchmark comparison in image. So let's check that. Let's check that. Okay, yeah. Mm, as you can see here, we have the inference time comparison, the inference time and the frequency. Mm, seems PyTorch is higher. The inference time to the ONX. Well, it seems good. Mm, yeah, yeah. So it takes less time when we are using ONX model. It's quite an efficient model. Mm, yeah. Okay. So we finished with that. Uh, we have our benchmark. I can see that uh, my my folder structure is a bit misplaced again. I have to move. I have to move some of the files to the scripts folder. As you can see, I can even see duplicates. Mm, okay, clean, clean the code structure. I see some duplicated Python files in the scripts directory, in the root directory, uh, and also clean it up and do some finishing touches. Mm, uh, and also the script related files to the script folder. Uh, okay, okay. So we are almost done. Uh, so using our AI assisted uh, coding, we were able to build this inferencing from a model, converting a model to another format, which in our case from PyTorch to an or NNX. Mm, and actually, I think we have done it pretty well. It has given us this labeled images with the different models we used. the ONNX and the PyTorch. It has also given us the comparison image, uh, what it gives while running the two models and the original image. And we also have a benchmark comparison, which is visually attractive graph that that tells the difference between the two models, in which we have found that the ONNX model is quite efficient and faster compared to the PyTorch model that we have used to inference the test image we have. Mm, yeah, and all in all, we have also mm, see that how AI assisted coding empowers us and engineers to deliver production ready and uh, with a good quality uh, code that work that works best, and in which it has also made our workflow faster. So I think that's what we demonstrated uh, in this uh, in this session. So as you can see, yeah, our folder structure seems a bit nice. We could have made this a little bit easier if we had made a rule for the agent, so that it will put all our script related files in the script folder, which I did tell it, but somehow it uh, didn't follow. Maybe I'll get back to that. Mm. But now it pretty much looks neat, and I think we have addressed all the points that we were asked on the assessment. Yeah. Let our agent finish this, and we'll pro we'll finish the session. Mm, okay. So now it's finished. Yeah, we have a clean code structure. Yeah, everything seems up to date. Perfect. So this is it. Uh, Thank you.